Hi, everybody. I'm Christie Wilson. I'm a software engineer at Google. Over the years, I've worked in a lot of different industries. I've worked in mobile, foreign currency exchange, AAA games, but no matter what I try to work on, I always end up gravitating back towards work related to testing and CI/CD. And so for me, Google has been no exception, and right now I'm very excited to be leading the Tekton project, which is what I'm going to be talking to you about today. So we're going to start off with an intro to Tekton and an overview of how it works, and then we'll get into some demos. So I'll be showing you a demo of Tekton Pipelines, and then I'll be welcoming to the stage Vincent Demister to demo the CLI and Simon Kagi to demo the dashboard. Then we'll talk about some ways that you can integrate with Tekton, and we'll finish off with where we're going in 2019. So how many people have some idea of what Tekton is? Okay, pretty good. And who has no idea and is hoping I'll explain it? Perfect. You are in the right place. So let's start off with the backstory. So some of you might know that Tekton actually started as part of the Knative project. So in 2018, Knative serving was created. So this is a way to have an open source serverless solution built on Kubernetes. And in order to have that, there needed to be a way to go from source to a deployment, and that's why Knative build was created. So Knative build let you build images in Kubernetes, which it turned out people wanted just that functionality alone. They thought it was pretty cool, but they quickly wanted to add more. They wanted to run tests before their builds, and they wanted to create more complicated pipelines. So we created Knative build pipelines. And then the scope just kept growing, so eventually we moved it out into its own org and created Tekton, and now it's a bigger project, but it still has pipelines at the core. So what Tekton is all about is cloud-native CI/CD components that are composable and reusable and portable between vendors. So we took a lot of what we were already doing in CI/CD for years, and we added a declarative typed interface on top of it. So the goal here is that eventually you should be able to start a project, and no matter how complicated the pipeline is, you should be able to run it against your own infrastructure. Or you should be able to take pieces of that pipeline and run them in isolation, or even take pieces and reuse them. So even though we started with pipelines and pipelines are still at the core, the project has expanded. So now we also have a CLI tool and a dashboard, and we're currently incubating some event triggering projects as well. And we're not doing this alone. We have regular contributions right now from engineers at CloudBees, Red Hat, IBM, and Salesforce, and we've put a lot of effort into trying to make it really easy for new contributors to join us. So if you're interested, please come by and check out our contributing guide. So before we get into the demos, I'd like to tell you a bit about how Tekton Pipelines works. So it's all about cloud-native components. And here, cloud-native means the same thing that it means for a lot of us. So it's an open source project, it's built around containers, and the containers are orchestrated with Kubernetes. Now, to understand how the pipelines work, the first thing to understand is that they are implemented with CRDs. So CRD stands for Custom Resource Definition, and it's a way of extending Kubernetes itself. So out of the box, Kubernetes comes with types like pods and services and deployments, but with CRDs, you can add additional types, and then you provide binaries called controllers that act on those types. So let's take a look at the types we have extended Kubernetes with for Tekton Pipelines. Our most basic building block is something we call a step. And a step is actually an existing Kubernetes type called a container spec. This is an image with everything that you need to run it, like what environment variables it needs, what volumes, etc. The first new type that we added is called a task. A task lets you combine steps. So those steps will run in the order that you declare them in on the same Kubernetes node, which means that they have access to the same resources. The next new type is called a pipeline, and a pipeline combines tasks. So now you can run these tasks in any order you want. They can be sequential, they can run in parallel, or you can create complicated graphs. They're not guaranteed to execute on the same node, but via the inputs and outputs, you can take the outputs of one task and you can provide them as inputs to another task. And so being able to make these more complicated graphs can really speed up your pipelines. So for example, in this one, we can do some of our quicker actions like linting and unit tests right away. And then as we move into slower activities like running our integration tests, we can at the same time build images and set up a test environment to get ready for our end-to-end tests. So tasks and pipelines are types that you define once, and then you use them again and again. Just creating them doesn't do anything. They just sit there in the cluster and wait until you create our next new types, which are pipeline run and task run. And those actually invoke the pipelines and tasks. And then our final new type is the one that you use to provide runtime information, like what image registry to use, what Git repository, and that's called a pipeline resource. So for Tekton Pipelines, we've extended Kubernetes with 5 types altogether. We have tasks that are made of steps, we have pipelines that are made of tasks, and then we actually run those using pipeline runs and task runs, and we provide runtime information with pipeline resources. And separating out this runtime information gives us a lot of power. So this lets us take the same pipeline that we're using to release from master, and we can run it on our pull requests. Or we can shift even further left, and our contributors can actually take that same pipeline and run it against their own infrastructure. So now we're going to see some of this in action, and you're going to watch me try to type while I hold this microphone. So I'm going to give you a demo of a pipeline run. OK, so prepare to see a lot of YAML. So pipelines combine tasks. So let's take a look at some of the tasks that we can be dealing with. So in this pipeline, we're going to use this task, which is called build push. And you can see in this definition here all of the inputs and outputs that this task uses. So it needs a Git repository as an input. It needs some parameters. And as an output, it's going to be building an image. And then here you can see the steps that are involved. So it's going to be using the Canico tool to actually build and push the image. And then we're going to also be using this task here, which is going to invoke kubectl to deploy to our cluster. And over here, you can take a look at the pipeline that uses these tasks. So at the beginning, the pipeline has to declare the resources it needs. So we can see that it needs a Git repository, and it's going to be using 2 different images. And since we know what tasks it's using, we can guess it's probably going to be building 2 different images. And down here in the actual tasks, we can see it's referring to the build push task that we were looking at twice, which means it's going to be building 2 different images. And then later, it's going to be using the deploy task that we were looking at to deploy as well. So let's create those with one hand. So I'm going to be adding the definitions of the pipelines and the tasks to our cluster. So at this point, they're just going to live in our cluster, but they're not actually doing anything. They're waiting for me to invoke them. And to actually invoke them, we're going to create a pipeline run. So this is a pipeline run. We can see that it's referring to the pipeline that we were looking at before, and it's providing the 3 resources that pipeline needs. So it needs a Git repository, and it needs 2 images. And for example, this Git repository is provided as a pipeline resource here, and we can see that this is the repository it's acting against, and this is the revision it's using. So let's apply that. So now that I've created the pipeline run, the pipeline actually starts executing. And so we can take a look, using kubectl, we can take a look at that. Oh, dear God. I appreciate, no. Is that actually close enough to my, okay. Okay, so here we can see. Thanks, Dan. We can see the pipeline run in action. So you can see that it was broken down into a number of task runs, which are all referring to the tasks that we were looking at. And if we wanted to see what was going on, we can further take a look at the pods. So let's take a look at the logs for this pod. I think I can hold it now. OK, so here you can see that this task is executing, and it's using Canico to build and push the image. So now, one thing that you may have noticed is that I'm using kubectl a lot, and there's a lot going on that's not related to Tekton, but is specific to Kubernetes that you have to understand to know what's happening. So at this point, I'd like to introduce Vincent Demister, who's going to demo the CLI tool that he and his team have been working on.
All right. Can people hear me? Yeah, okay, perfect. All right, so I'm Vincent de Mester, obviously. I work at Red Hat on the CLI project on Tekton and the past month on the CLI. And I'm going to show you the CLI. So the CLI is here to provide you a command line that is focused on the pipeline objects. And so you can use it without any prior knowledge of the actual kube command and the YAML. So please bear in mind that the project is about 1 month old, so the feature set is currently quite small, but we are going to add more and more on the past few months. So the command line is called tkn, and as you can see, we have 4 useful subcommands: pipeline, pipeline runs, task, and task runs. So let's just list, for example, the pipelines we have available on the cluster. And we can see the pipeline Christie just created. We can also list the actual tasks. English keyword. Right now, so we have the free task too. Same thing, we can just list, for example, the task runs. Here we can see all the task runs and their name. So all of those were created by the pipeline run. And if I want to filter, like at some point it's going to have a lot of task run probably in your cluster. If I want to filter them by, I don't know, 1 task reference, I can just type the name of the task, and it's going to show me only the task run related to the task build push. And finally, we can just list the pipeline run and see if they succeeded or not. And for example, this is the actual run. And the last thing I'm going to show you is the logs. So if you want to see the logs of the pipeline or a task using kubectl, you're going to have to look at the status of the task and then find the pod name in there and then do the kubectl logs. Here we can just say, okay, I want to look at the logs of this pipeline run. And it's going to show me the logs. Yeah, okay. So here we can see the logs of all the tasks. So the tasks are here. This is the actual steps. And yeah, that's all for the CLI so far. We are going to add more like detailed visualization of your pipelines or the steps in your task. How to trigger and create tasks without knowledge of, without using kubectl. But sometimes, how do I switch? Sometimes you don't need, like command line are awesome, but sometimes you need a web UI, like a dashboard. And for that, I would like to introduce you Simon Kagi, who will demo the the Tekton Dashboard project.
So let's go back into present mode here. So the Tekton Dashboard, similar to the Tekton CLI, it's a project that's about 3 months old. First and foremost, it's there to create a web UI for Tekton Pipelines. It's designed to be very, very simple, similar to the Kubernetes dashboard. A single container, a Go executable, and we embed the static web UI inside it. So it's really, really easy to get going. We say it's similar in spirit to the Kubernetes dashboard because when we first created the dashboard, we wrote a whole whack of JavaScript creating custom renderings for all the various Tekton resources. But what we found is that doesn't work in the long haul, and these are things that I think SIG UI and SIG CLI has found. So now we're much more metadata driven. And we're looking to SIG UI and SIG CLI to help us with things like versioning discrepancies, which are things that are going to be critical for Tekton. Finally, we're not imagining that the Tekton dashboard is going to be the be-all and end-all of all CI/CD UIs. So we're building it out of reusable components, and we're also building in an extension mechanism. So the idea here is that although you might not be using the Tekton dashboard, you can always go there to take a look at our components and get ideas for how you might want to do some of the tougher tasks like rendering a task DAG or look at our lists and details views. We're very fortunate on the Tekton Dashboard to have a lot of designer support. So what you see on the left is what we started out with. That's a pure developer design. And then when we took it to the designers, they had different ideas. What we're working on right now is merging a lot of the concepts from the Kubernetes dashboard into the Tekton dashboard. And we're, above and beyond that, though, we're looking to create detail views, like what's shown up here, which is a task DAG, and list views. There's some interesting challenges in Tekton. So, like, if you look at it, you might think, oh, everything's hierarchical. A pipeline breaks into pipeline runs, breaks into task runs. But what you actually discover is that there's actually connections all the way through. So you might be able to go, you can travel from a task run up to a task. So there's some unique navigational concepts that we're working through in Tekton. All right, so now I'm going to show you a quick demo of, a recorded demo of where we were actually last night. All right, so what you're looking at here is our basic pipeline view. As I say, this is where we are in terms of development as of last night. Notably, things that are missing that are going to be added very soon is a search bar at the top. This is really critical. When you're navigating around in a pipelines, you use labels a lot. Down the left, we have our categories. This list is extendable. We have a namespace concept that you can use for filtering, and I'll show in a minute. And we also have extensions. Right now we're missing task runs, but that's something that's going to come very shortly. What I'm going to do now is I'm going to drill into a pipeline. So we get a new pipeline run list view. There will be a detail view there. Here we have tasks, a list of tasks, and within the tasks we have steps. And you can look at them and see logs, which is just a cat of a file, the status of the step, and the details. So you can actually see what the step was running in the first place. Across the right, we have breadcrumbs, but you might drill into your pipelines in different ways. You might drill in by pipeline runs or by task. And so let's just take a look at one last task. This is a build push run using Canico. The log view is markdown. We can render glyphs and links. And so this one failed because we couldn't push to Christie's cat factory repo. Namespaces are just filters. So I actually ran this on IBM's Kubernetes service, but there's no Kubernetes resources in cert service, back to default. Extensions are another piece that's really critical. So right now we're doing experiments in triggers, but you're going to need to provide UI for that. And how do you go about doing that? And we also believe that the types of extensions that you're going to use there are going to vary quite dramatically. So what we have right now is something that lets you extend in and build in just about any UI that's built on top of the Kubernetes CRDs. But in the future, we're looking to make extensions that you can have without having to write any JavaScript at all, just built on the pure metadata that Kubernetes has. So in this way, if you write CRDs and you augment them to work well with kubectl, they'll also work well with a Tekton dashboard. So again, we're lucky to have lots of designer support. Oh, and that didn't render very nicely. The designers will be devastated. But one of the things that we're playing, we have the opportunity to play around with stuff. So one of the ideas we're playing around with is when you're viewing a particular pipeline run, you might want to see the current pipeline run, but you also might want to see the pipeline run before. And so this is especially useful when the current pipeline run has just failed, so you can immediately get back to the last passing pipeline run. Again, another really difficult problem is how do you display these DAGs What we find is the designers come to us with lovely designs that treat the build pipelines like they're going to be a very simple, straightforward thing. In reality, what we find is that the DAGs can be quite large and complex. And so we're doing a lot of work trying to figure out how to render these things. So that's a snapshot view of the Tekton Dashboard. We're having a lot of fun right now figuring out how we want to render these things, and it's challenging. And we're hoping that others can help us out here. But we're charging ahead. It's a great project. Thanks.
Okay, thanks very much, Simon and Vincent. That was pretty cool. So if you also thought that was cool, you might be wondering how you can actually start using Tekton. So I'm going to go over some of the patterns you might use to get Tekton working with your CI/CD tools. So I'm going to go through a few different options here, and the difference between them is going to come down to how much or how little of Tekton you want to expose to your users, whether you want to use Kubernetes or not, and how portable you want pipelines to be. So the first and most obvious option is just to use Tekton directly. So this means that you would be running Tekton, and your users would be using all of the Tekton types like pipelines and tasks to interact with it. So this will give you the most advantage of the Tekton features, but some of the things that you need to actually make this happen are currently works in progress, and also it means that your users will be using the Tekton syntax, which some people find really verbose. A related option, if you work on a CI/CD tool, you could create a task that wraps your tool, and then you can contribute it to our catalog. And that means that anyone who's using Tekton or using a project that's integrated with Tekton will be able to use your tool with their workflows right away. Something else you can do that takes advantage of the interface and also takes advantage of the catalog is to implement the interface yourself. So even though it's a Kubernetes-based interface, it doesn't actually have to be implemented with Kubernetes. So if for some reason you have restrictions that make it so you don't want to use Kubernetes, you could use this option so that you have the same interface, you can support all the tasks in the catalog, but you can control everything that happens underneath. The option that we're seeing most commonly right now is for you to create your own DSL, which can compile down into Tekton types. So this means that your users would be interacting with your DSL, but you could provide, if you wanted, a break glass mode so that if users need to go beyond what your DSL provides, they can actually go straight into the Tekton types. The biggest downside here is that supporting compilation from your DSL to Tekton and then also the other way from Tekton back to your DSL might be impossible. So you might actually lose a little bit in what pipelines you can have people bring to your application and what they can bring out to others. And then a similar approach, which is pretty much the same thing but without the break glass mode, is to hide Tekton completely. So in this mode, you would lose a lot of the Tekton advantages, but you could still use some of the cool stuff that we're working on, like for example, the ability to run multiple steps on one pod in order and to have sidecar support, but you don't have to get tied into Tekton. This can also be a good option if you want to try it out, but you don't want to expose your users to it, and you want to wait for our API to solidify a bit. And then maybe the simplest option that would be the least work is to just invoke Tekton from your tool. So we were hearing about Spinnaker earlier. This is similar to how Spinnaker integrates with Jenkins in that you can have Spinnaker pipelines that call out to Jenkins jobs and then watch those jobs and wait for them to finish. You could do a similar thing with Tekton. So there are a lot of different options here, and the things to consider when you're evaluating them are, do you want your users to be interacting with Tekton syntax directly? How easy do you want it to be for people to bring their own pipelines to your tool, and whether you're using Kubernetes? And can you handle the fact that the API is currently in alpha and might actually be changing? And so speaking of the API being in alpha, let's finish up with a look at what we're doing with Tekton in 2019. So at a high level, our main goal is to get to a 1.0 or beta release so that you can start to count on a stable API that won't have backwards incompatible changes between versions. So this quarter, what we're working on is the final pieces that are needed so that you could use Tekton as a complete solution for your CI. And then for the rest of the year, we're going to be working on other cool features and hardening that API. So specifically, the missing features we're working on right now are event triggering, log persistence, and support for SCM tools like GitHub and GitLab. And so the goal here would be that you would be able to set up triggering from your GitHub or GitLab project straight to a Tekton pipeline, but using only Tekton components. And then for the rest of the year, we have a somewhat ambitious list of features that we want to add. A lot of these are things that most CI/CD tools already have, things like conditional execution or manual approval via pause and resume. And then we want to add some things that other CI/CD tools tend not to have, like strong typing around images. We want to have a strong extension model so that you can extend Tekton with your own types without having to recompile it or upstream the changes. And so if you're interested in this, please come to our working group meetings and join our mailing list. So if you go to the community repo in the Tekton CD org, that's the best place to find up-to-date information about that. And if you want to just jump right in, all of our projects have contributing guides and quick starts, so please join us. And that's it. Thanks very much.